Williams percentage R is a bounded oscillator that compares a stock price to its past range's maximum high. 14 days are commonly used in its calculation. For full reference, I recommend that you visit Larry Williams' website at williamspercentager.com. Its calculation has the following steps. A. 14 days maximum high and minimum low calculation. High or maximum high of 14 days is equal to the maximum high price of 14 days. Low or minimum low of 14 days is equal to the minimum low price of 14 days. B. 14 days Williams percentage R calculation. Williams percentage R of 14 days is equal to the maximum high of 14 days minus the close price divided by the maximum high of 14 days minus the minimum low of 14 days, and this result is then multiplied by minus 100. Great, so let's go back into our Python PyCharm IDE so that we can study Williams percentage R with greater detail. Excellent, so here we are back within our Python PyCharm IDE. In this lecture, we'll be working within Williams percentage R code file. If you have any questions about its setup, please go back to section 1, Stock Technical Analysis Data lecture, where all of that explained with greater detail. So as these are meant to be standalone type of files, first we need to do our packages importing NumPy as MP, Pandas as PD, Matplotlib as PLT, and Talib as TA. Then we proceed by default to do our data reading by creating our SPY data frame, which is equal to PD or pandas.read_CSV. Then we have the corresponding path to our data file, which is right over here within our data directory, and it corresponds to that txt file, which includes CSV or comma separated values. Index column equals date, and we parse those dates as true. Then we proceed to do our technical indicator calculation. In this case, we create SPY, WPR or Williams percentage R column, which is equal to Talib's.WILLR or Williams percentage R. We then provide MP or NumPy as array, high, low, and close prices, and then we define as parameter time period of 14 days. As always, this is the time period used commonly with Williams percentage R, but you can modify it as well for your needs. Excellent. So then we're going to do our corresponding chart, which is Fig1, AX or axis equals PLT.subplots, two of them which share the X or horizontal axis as true. Then on the first of that subplots at position 0, we're going to plot close prices and the legend located at the upper left. Then on the second chart at position 1, which is just below those close prices, we're going to plot our SPY Williams percentage R, colored in green to differentiate from our close prices with its legend located at the upper left. Then we're going to add PLT superior title of these two subplots, which is going to be SPY close prices and Williams percentage R for 14 days, and we're going to show this chart. So let's proceed to run the code by clicking the right button on the mouse and scrolling down into Run Williams percentage R. Excellent, so here we have our chart. Let's make it a full screen. Needs to be done manually because of the screencast right over here all the way, and also right over here to the bottom. Perfectly fine. So here we have our SPY close prices and Williams percentage R of 14 days technical indicator. Top chart corresponds to our close prices in a blue solid line. Then we have our technical indicator. They share the horizontal axis, which are those dates, beginning in 2016 and ending at the beginning of 2017. And here we have our corresponding Williams percentage R technical indicator, which we'll study later on in our following sections. Excellent. So let's close this chart here, this other charts as well. Excellent. So with this, we finished our corresponding technical indicators. We began with those lagging ones through moving averages, Bollinger Bands, parabolic stop and reverse. Then we continued with the leading ones, which were oscillators charted at the bottom of the price chart. We began with average directional movement index, then with commodity channel index, moving averages, convergence, divergence or MACD, rate of change, relative strength index, stochastic oscillator, and finally with Williams percentage R. So now that we've finished studying all these technical indicators, it's time to continue with our following section in which we'll study how these technical indicators generate the corresponding trading signals, both individually and also within multiple indicators, and that is going to be our following objective.